So a question about how to know what type of trend line we need to use. I think we may have a video about this one. Let me see. Blah, blah. Module 5, let's see. We had last night's really short Zoom session because only one person came. Let me see here. Maybe not. It seemed like we had a video about this. So you might check some of the earlier weeks, but again, how to know whether you have, whether you should use a trend line with polynomial of the second degree or third degree, or the order of 2, order of 3. They're essentially saying, do you want to have, if you do it of the second order, then they say, do you want squared terms in there? Like we had with average total cost, we said that had a squared term. Average variable cost has Q and Q squared. Marginal cost has Q and Q squared. All of the terms that have just squared terms in them will have underlying data points that look U-shaped, either U-shaped or hill-shaped. So they'll only have one kind of change of direction in it. So again, if you're U-shaped, then you're decreasing, but then you have this change of direction when you start to increase. If you're hill-shaped, like some of the total benefit or total revenue or total product curves, those were sort of hill-shaped, and you had single changes of directions there too. So you started to increase, and then you sort of change direction, and you start to decrease. That would be a U-shaped curve, or that would be what we call a quadratic. So if your data looks like that, if it has that kind of U-shape or hill shape to it, then it's usually best to use a polynomial of order 2 or a quadratic type of equation to describe it. If you have something that has 2 changes of direction in it, like may have happened, I don't know if I have any of the slides here. Let's see, probably the total cost might have it. Total cost has it. So it might be kind of hard to see, but you can see that this total cost curve is rising, but it's kind of decreasing in its slope. So it has, it's rising a little bit, then it starts to change direction a little bit where it starts to flatten out. And it doesn't continue to flatten it. It doesn't, even though it sort of looks like the beginning of a hill. If you looked at just this leftmost portion of the total cost curve, the blue dotted line, it looks like it could be nearing the peak of a hill. If it was just hill shaped, then you could sort of envision that this part that's rising, it's increasing, but it's starting to slow down. You can imagine it might have been near the top of a hill and then continue down. If it looked like that, you would say that's a quadratic. That would be a term that had a Q and a Q squared term in it. But it doesn't do that. It does start to slow down, and then it starts to pick up again. So it kind of has this S shape to it. Probably the best way to describe it. You have your U shapes or your hill shapes. Those are both quadratic. If you have an S shape to it, then that's going to be best described with a cubic term, a term that has a Q and a Q squared and a Q cubed term in it. I don't know if it's necessary to have that. You might end up running regressions where some of these variables might end up showing up as insignificant. Like if you might have a total cost function where maybe the Q term is insignificant or the Q squared term might be insignificant. But usually your Q cubed term, if it's still significant, would kind of indicate that it has this sort of S shape to it. If you try doing, if you had a U-shaped or a hill-shaped data set, and you tried running, if you tried describing it with a cubic function, so you have this U-shaped thing, like one of the cost curves from before, one of the average or marginal cost curves from before. I'll use this one, I guess. Well, this is profit max. So if you have an average total cost curve that looks like a U, or the marginal cost curve that looks like a U, and if you had those data points, you can go in there and do this, because again, you can go in and look at the data yourself if you want. You could try going in there and putting in a trend line. Well, you wouldn't be able to do that because you can't see whether these things are significant or not. You could look at the data and you could make a Q, I mean, you'll already have a Q column, but you can make a Q squared and a Q cubed column if you wanted to. And then you'd have marginal cost as your dependent variable. And you could try running two sets of regressions. One of them would be marginal cost, and then as your dependent variable, and you'd have Q and Q squared as independent variables. And you could do a second regression with marginal cost as your dependent, and then Q, Q squared, and Q cubed as independent variables. And my hunch is that since marginal cost always has this U shape to it, that it'll probably show your Q cubed term to be insignificant. It might not, but it might. My guess is that it probably would. It might do that just because there's not a whole lot of extra data on either sides of these things. So it might end up showing it as significant, but I wouldn't be surprised if it did not, if it showed a Q cubed term to be insignificant because it is U-shaped. But generally, again, if you have a U shape or a single change of direction in something, then it's best described with a quadratic or the order 2, polynomial order 2. If you have an S-shaped sort of thing, like most of our total cost curves have been, then those are best described as cubic functions or polynomials of the third order. All right. Would you use price greater than average cost of price, not greater than total cost, to determine if to take a loss and keep the firm open? Yeah, if I go to slide 15, there's this, as it says, this summary of short-run decisions. So I'm always looking for where this price is in relation to the marginal cost curve, because that tells me where we want to operate, the quantity that we want to set. So if the price happens to be, I'll just draw a line in here, insert shape, draw a line. If the price happens to be somewhere way up here, I'll hold my shift button down to make sure it stays nice and straight. And let's see, can I do this in kind of a weird shape so it'll look distinct for us? That's a good one, I guess. And can we do it in a weird color? Orange, bright orange, or teal? We'll call this teal. So if this was the price, my little teal line here, then the first thing I do is I figure out what quantity does this company want to set. And the profit maximizing quantity, just like when we said when we were doing the optimization chapter, it was always what's the level of activity you want to do? Well, the level of the activity you want to do is where the marginal benefit intersects the marginal cost or equals the marginal cost. So the activity here is deciding what quantity we want to set, because the price is pretty much determined for us for these firms, these perfectly competitive firms. So I look for where the marginal benefit or the extra money coming into our company, which comes from the selling price, is equal to the marginal cost of producing it. So the output that we're going to pick is associated with this intersection here. And so if you can imagine the quantity associated with that. Then you go, okay, well, the price line, the teal line, is how much money is coming in. And let's think about our expenses, our costs relative to that price. And here, this price is much higher than our total cost would be at that quantity. So we're certainly making a profit in this case. That's why anything above, anytime you have a price that is above where the marginal cost intersects the average total cost, it's going to be profitable. Even if I pull the price line way down here, I can say, okay, well, I know the quantity is this intersection here, not this one where the dotted line is, but this is going to be the optimal quantity for us, so whatever quantity that's associated with. And I can still see that that price is a little bit above the average total cost. So I still make profit here, not a whole lot, not as much as I had in with the price when it was way up here. But even if the price is down here, we still make profit. We're covering all of our expenses, plus we have a little bit left over. If you get to the point where it's right on the line, like that, then you'd still say, okay, the quantity we set is where price intersects marginal cost. So now it's where all three of these things are lining up. And I say, well, the price, the money that's coming in from selling this thing, the marginal revenue we're getting, or the marginal benefit we're getting, now it's exactly equal to the total cost that we have to pay, the average total cost we have to pay. So price equals average total cost now. So we basically break even. And again, for these kinds of companies, if you break even, that means you're covering all of your expenses, including the time and effort and stress of having to run this business. So you still feel like you're getting enough of a revenue to cover all of those expenses. So you still say, okay, I still feel, okay, we're going to keep going today. We're going to open today and keep operating. Once the price starts to drop below this top dotted line, Then again, you'll do the same thing. You go, okay, well, the quantity we want to set is where this price, the teal line, intersects marginal cost, which is right here now. That's the quantity I want to set. And I think I stressed enough that in the video, there's no other quantity that's going to be better than this. So you might say, well, why don't we try, if this quantity is going to lead to a loss, and I know it will, because at this quantity, this is the price coming in, the teal line, and the total cost is up here. So now the total cost is higher than our revenue. The additional total cost that we bear is greater than, the total cost that we bear in an average sense is greater than the money coming in. So we are taking a loss. You can't find any other price or any other quantity that's going to give you a smaller loss than this in terms of total losses. You might find it on a per unit basis, but we're interested in maximizing total profit, not just per unit profit. So this is the best quantity here. And again, you see that, again, that price is below the average total cost. So if the price is not greater than average total cost, yes. So this is a situation where we're taking a loss, and the question though is, okay, so do we shut down? Do we shut down in this case? And the thing to think about, the thing to remember, I guess, is that you can have those situations where a company might say, yeah, we're taking a loss this year. We're not making enough revenue to cover all of our expenses, so we have a loss this year. And let's say you have a company that does, $1 million in sales. And so you're doing $1 million of sales, and your accountant comes to you and says, I have bad news this year. We made $1 million of sales, so that's good. But our expenses were $1,010,010. So we had $1 million of expenses plus an extra 10. So the guy that went out to get donuts that day, we shouldn't have had him do that. So you have $1,010,000 of costs. And you would say you'd have a loss that year. You'd have a loss of $10. Let's say your fixed cost for running your business was $100,000. So you have $100,000 of fixed costs. That's part of your $1,010,000 of expenses. Again, would you say, oh, well, we ran a loss this year. We better shut down. We better just not produce anything this year if we think we're gonna operate at a loss because we had a loss of $10. Well, no, because shutting down means that you lose all of the revenue and you still have to pay all of those $100,000 of fixed costs. So if you stayed open, even though you had this loss of $10, you would still say, well, a $10 loss is better than shutting down completely and having to pay these $100,000 of fixed costs. So anytime that the price is in this range, in this yellow range here, that's going to be a situation where you know you're taking a loss, you're not making profit, you're not even breaking even. But you would still say, well, it's better to take this loss because the loss we're taking by staying open is still less than the loss we would bear if we had to shut down completely and pay all of those fixed costs. And you can tell the amount of fixed costs is basically the gap between these two curves, the average total and the average variable is sort of the gap between those two things. But anyway, so like you said, if you're way down here, or I'll just go even below it. Well, I guess I can't really go below it because the marginal cost curve doesn't go below it very much. But if you ended up having where the price can't even cover your variable costs, so if the price was way down here, then you'd say, well, our price is so low that we can't even pay our variable expenses. I know we can't pay our fixed costs. We can't even pay our workers either. So this would be a situation if the price is way down here that you would say, well, now it's a situation where if you're operating in this situation, it would be kind of like we have our $100,000 of fixed costs, but operating would lead us to having $200,000 loss. We would have a $200,000 loss, including our fixed costs of $100,000. Well, in that case, you would say if we stayed open, then that would mean a $200,000 loss. If we shut down and only had to pay our fixed costs, that would be a $100,000 loss. So it would be better for us to shut down and only have to pay those fixed expenses. You could, if you wanted to, you could go in and play with some of the other graphs that we have here, because you could sort of recreate. I mean, I mentioned here the total profit. You could calculate this and figure out that it is $14,750. You could go in if you needed to go open up the table. You could go in and actually figure out how I calculated this and how I got this 14,750 number. Same thing over here, how I figured out what the loss was, 3,185. You could keep playing with it and say, well, what if the price was below the minimum point of average variable cost here? Like if the price was $21, I don't know if the marginal cost goes up to looks like 22.2. So if you tried going to, figuring out a price of 23, let's say, which would be just above the average marginal cost, it would certainly be below the average variable, because it looks like the minimum point of average variable is 28.60. So you could try a price of $23 or $24 and figure out what the loss would be, and your loss is going to be your loss is going to be greater than the $6,000 if you did that. If you tried a price that was even below where the average variable cost was. So let's see, a price greater than average variable cost and a price not greater than average total cost. That would be that'd be a situation where you'd have a loss, but you would stay open. All right. What range should we have Q for question 4B? Well, that is going to be something where you might want to think about it. You should, if I mentioned here that you can format the axis to zoom in to your graph in Excel, you should get to a point where you can see, if you do your proper zooming in on your graph, not the video chat situation. If you do a proper amount of zooming, you should end up being able to look at a picture that looks like our normal cost curve pictures, where you have your average total cost, average variable cost, marginal cost. So if you're looking at it and everything looks really squished, like you have these lines that are just horizontal lines, then that means your Y range is probably too big. If you see a picture and it's just more like vertical lines, then you probably zoomed in too much. So there is kind of a sweet spot where you can zoom in enough where you are going to be able to sort of look at a picture that does look sort of like this. And there are, well, I'll leave it at that. Would you enter the market if you were brand new and the price was more than average variable cost but less than average total cost? Well, that's basically something I'm asking you guys to do in this graded assignment, so I can't tell you the answer to that. That'll be something you'll have to think about for yourself. If I was in that situation, would I want to do that? So, is the recording going? Yeah. Anything else? I managed to cover the 4 questions in the chat. If average product is less than marginal product, does that mean average product is rising? You can think about it this way. Instead of thinking about average product and marginal product, you can think about it as average test score and marginal test score. So if you had an 85% as your test average, or your EOM average, let's say, if you had an 85% on your EOM averages, and then the next one you got, the next EOM that you did, EOM 5, let's say you got it 100% on it. So for the first 4 assessments, you averaged an 85%, and then on your 5th one, you got 100%. So the next test you took, the marginal test that you took, test number 5, if that one was 100%, then that would end up pulling your average up. You might have had an 85% average over the first 4. But once you got 100 on number 5, since that marginal one was greater than your your earlier average, it's going to pull your average up. So your average might go from an 85 up to an 87 or something like that, an 89. So yeah, if your average product is less than the marginal product, then that's going to actually pull the average product up. If the next thing you do is better than the average of what you've done before, it's going to start pulling your average up. And it kind of goes in the other way too. If you had a certain average and then the next thing you do is worse than your average, it's going to start pulling your average down. So hopefully that makes some sense.
Professor, I have a question in the practice problems, number 1. If you can please share the Excel file.
Sure. Let's see this one. And this was just this is just the table of data. Yeah. So there were 2 Excel sheets. One of them was just this set of data.
Yeah.
Okay. And this is the answer key. So, all right.
Okay. So here we did the 2 regression analysis. One has L squared and L cubed. The other one has only L squared and L cubed. We found out that L has a large p-value. That means it's super insignificant. It's not significant at the 10%, which is our goal. So that was the case here. What would, if we did, like if we run the regression and we found out the p-value of L is at 0.7, for for example, would you take this into consideration, or would we still take it off and just have L squared and L cubed?
It's it's I've said before that what you should usually do as far as whether you want to include or exclude variables is to think about what the theory tells you. And that's a little easier to use when you're talking about pizza demand and the price per slice and how big the city is and whether it's an urban area and stuff. Here it's, I don't know, these variables don't seem to be make as much, they're not as intuitively obvious what they're supposed to represent for us. So for me, especially if I go over to like this one over here, where I included L, I can see that its p-value is really low. Or sorry, its p-value is really high, meaning its level of significance is really low. So I'd be tempted to probably toss it. The other thing too is that the coefficient itself is really, really small. I mean, I have to realize that the size of the coefficient does depend on the size of the underlying data versus the size of the dependent variable, but I'm getting that it's insignificant and it's really, really small. So I'd kind of be okay by getting rid of it here, which basically means that you end up with this regression down here. Up here, it shows up as significance, but still, its coefficient is really, really small. And again, this is not like a situation where you would say, well, if the dependent variable is the demand for pizza, if this variable was the price of pizza and I get these things, well, I should just throw it out because the results are so bad. Theoretically, I say, no, I mean, the price of pizza is really important in describing how much demand for pizza there is. But when I've got this thing where it's like, I've got L and L squared and L cubed, well, L squared and L cubed are still kind of, they're kind of accounting for the effect that labor has on output. So it's not just the L term itself that's telling me how much effect an extra worker has on output, because L squared and L cubed do the same thing. They're just, again, transformations of this L variable. So if I get rid of L here, it's not like I'm just tossing out the notion that labor affects output, because I'm still accounting for that just in kind of a different way by including the L squared and the L cubed terms here. So even though this shows up as significant, its coefficient is really small, and I could look at the other things too. I could look at the R squares, both when you include it and when you exclude it. I could look at the fact that, you know, these other coefficient signs don't really change very much. They don't change significance when I get rid of it. So I'm tempted to say either of these two regression results on the bottom are, if you decide to drop the L's in the top ones and go with the ones at the bottom, it wouldn't cause me too much stress. I'd be like, okay, that seems to be a decent enough assumption. Okay to drop the L's in this particular example.
So what if we have the coefficient for L in a coefficient with like 19? It's not super small, or 20 or 21, and the p-value is like 0.7.
I hope this isn't like the actual results you got for the assessment, because I can't speak to that. Again, it would just be, you kind of have to take all those things into consideration. So the fact that the coefficient is small, that was one of the aspects that sort of went into my decision of whether you should include it or not. So again, it's the p-value, it's the fact that, well, this variable is the idea of L affecting Q is accounted for here, but it's also accounted for in these other independent variables also. And I look at the R squares and they haven't changed much. I look at the other coefficients and they haven't changed much. Their significance levels haven't changed much. So by getting rid of it, I'm not really affecting my results all that much. I'm just making them a little bit neater, I suppose. I don't have to include these other variables that don't seem to be that necessary to generate results that are pretty much exactly the same. It would be weird if I drop this L, if I drop these L's, and the coefficients for L squared and L cubed changed a lot. So these numbers here changed a lot, or the R squared, adjusted R squared, if those changed a lot, or if L squared and L cubed used to be significant, but then they ended up being insignificant, or vice versa, then I might kind of say, well, let's hold off a second. Maybe we should keep these in here. But since none of those things have really happened, again, I'm not going to lose a whole lot of sleep by dropping those L's in this particular case.
Okay.
For any question for what may I have done wrong to get a total revenue that's simply less than total cost? You may not have done anything wrong. except for not thought enough about what this problem is actually telling you. I've gotten several, at least one email about this particular issue today, and I just point people back to slide 4. So if you look upon, meditate upon slide 4, it might give you an idea of why you're getting the results that you're getting, where it is that your revenue might be kind of low and your total cost might be kind of high. So. Anyone else? Much more busy tonight than last night. Everyone must have been eating turkey and I don't know if there's a way to put a poll. Is there a way to have a poll? Zoom. Oh, there is. Let's see. Okay, polls. I've never done this before. Add a question. Whoa. My meetings. You have not created a poll. Add poll. Is this going to show up right now? Okay. Untitled option 1. Can I change what these? Oh, there we go. This is my first time ever playing with these polls, and since you guys aren't asking any more questions. Okay, so let's try that. So is this showing up? Is the poll question showing up for everybody? The question itself isn't showing up, but you might see it in the title there. I'll see launch polling. Okay, in progress.
Yeah, it's showing now on my side.
Okay, so my question is, mashed potatoes at Thanksgiving, yay or nay? Should you have mashed potatoes at Thanksgiving? Well, gosh, I should wait for my poll to finish. Okay, 5 people in voting. Your grade in the class may hinge on this. I'm just kidding. People voted. There's probably people that are working on their assessment or they're doing something else and not paying attention to what exactly we're doing right now. I'll let it go for a minute. Okay. Ooh, the nays are catching up. That's unfortunate. 5 seconds left to vote. What if it stores this somewhere? Let's see, end polling. Sure. Can everyone see these results? So almost split. And I should say this too. Well, there probably wouldn't be a way to do this. I was going to do another poll that said, are you from the South? Because when I grew up in Michigan, we always had mashed potatoes at Thanksgiving. And turkey was the only meat that was there. We didn't come out with this ham. There was also no mac and cheese. That seems to be a thing at Thanksgiving here in the South, mac and cheese. So I'm always kind of curious as to, but if I did another poll about, okay, so almost half of you said that you said nay to the mashed potatoes at Thanksgiving. If I did another poll that said, are you from the South? I wouldn't know. Some of you might have said yay or nay, but I wouldn't know if people who answered yes to the mashed potatoes question are also not from the South, which is what I would expect. And the people who said no at the mashed potato question were from the South. So that'd be one of those things you have to have more sophisticated polling services to do. Yeah, I just thought that was odd. Like, where's the mashed potatoes here at my? Luckily, my mom moved down here, so we got to have mashed potatoes at our Thanksgiving yesterday. And then the 2-year-old had mac and cheese. None of the rest of us, though. Anything else? I'll mention this too, since we're starting to get to that point of the semester where people ask this. because people have downloaded the Excel grade calculator and they've gotten to the point where they're putting in some numbers and they're like, "Ooh, looks like I'm on the borderline." And so now I'm starting to get inundated with emails about, is there's things I can do for extra credit? Are there extra things I can do to bump up my grade? No, there's still the EOM for today, this week. There's week 6 and 7, 4 things for each of those weeks. So there's still 8 more chances for you to bring your grade up, to have your marginal grade improve your average grade. So that always seemed a little odd to me, that, yeah, just the idea of extra credit, which means that I need to do something else over and above what everyone else in the class has done. So that in and of itself seems kind of unfair. Like a person gets an extra chance to do something which the rest of the class did not have access to. And then it's like, well, especially in this class, when you get 7 times 4, except for the first week, so you get 27 opportunities to do things that are graded in this class. Do you really need 1 more thing or 2 more things to bring your grade up? And then just if we can relate this to your job, if someone gives you a job to do and you don't do it very well, then they get mad at you about it, they're probably not going to say, okay, well, even though you messed up this job, if you can do this other job well, then that'll be okay. I'll just forget about this first job you completely messed up on and started the fire in the office kitchen. No, it's like you have to do well with things that you're assigned to do, and we don't want to invent new tasks for you. So I've never been very excited about giving extra credit. First of all, it means I have to make something else for people to do, and I have to grade it. So there's still, like I said, the glass half full version of this lecture is that there's still 8 more chances for you to demonstrate what you know and to pull things up to where you need them to be. And I'm kind of nice in telling, I'm somewhat nice in telling you that, no, I don't like doing extra credit stuff. And we're in week 5. When it gets to be the end of week 7 and I'm getting ready to have grades due, and I get 16 emails a day asking for extra credit, or even after the class is completely over, and people saying, "Oh, I just figured out my final grade and now I'm at this grade. Is there something I can do?" I've become much less nice. I don't ever let you know this. I just don't respond to emails that come in at that point asking for extra credit. But if you were in town, like if you ran into me in Walmart or something and said, I got a this grade, can you do something to bump my grade up 5 extra percentage points? I'm not going to be as nice to you in the Walmart. But you might not even know this because we're at Walmart. So a rude fellow customer might not be that discernible if you're at Walmart. I don't know, people make fun of Walmart, like the people of Walmart. I don't know if people to be that different from Walmart versus other places you can go. So you can find pleasant people almost anywhere. You can find grumpy people almost everywhere, and weird people almost everywhere too. All right, I spent like 10 minutes talking about nothing because no one else has asked other questions in the chat. So I'm running out of material. Which means I should pause the video. So a question about calculating the average total cost if you're given total cost. So again, you can try for practice, do the practice problem part 2, number 2. So the second set of slides after this fancy colored one. But I give you a table of quantity versus total cost, which let's see, you'll see at the top here. So in gray, this is kind of what you start with. Okay. And you can, let's see, the way I ask it, use OLS or use regression or trend lines, whatever, to get an equation for total cost, and then make these other things. So you're gonna have to either, like I said, either run a regression, or I just did the trend line with show the equation, show the R squares. You could run a regression and see that you'll get pretty much the same results there. So now I've got this equation here, and I say, create columns for average total cost, average variable cost, marginal cost. You could creating columns for those things might just mean putting these, these labels in the headers, but you do actually need to put numbers in this part of the table. So you need to figure out how you're going to calculate that. So if you have an equation for total cost, which is what the regression allows you to do, the regression allows you to figure out how Q and TC are related. One thing that you will have to do, which I don't really show explicitly, is if you're going to actually run a regression, you're going to need to make, especially, well, if you're going to run a regression that has Q squared and Q cubed terms in it, then you're going to have to make extra columns. So you have to make a column of Q squared, a column of Q cubed, and then use those as your independent variable. But once you're able to figure out what that equation is, either by running the regression or looking at your trend line equation, then it's just a matter of calculus and algebra to get the average equations. Just a matter of algebra, I guess, because you're dividing by Q to get the average equations and then doing the derivative to get the marginal equation. So average total cost is, like I said, total cost divided by Q. So I've got my total cost equation here, and I just need to divide every one of these terms by Q. So this is 0.00002 Q cubed, and dividing that by Q just takes off one of these Q's that's being taken to an exponent. So that first term just becomes 0.00002 Q squared. The next term, 0.083 Q squared. I get rid of one of those Q's, so it's just 0.083. 46.5 Q just becomes 46.5 because you're dividing that. The 5,000 doesn't have a Q in it, but since you're dividing every term by Q, you're going to end up with 5,000 over Q. The average variable cost means that you have to figure out what total variable cost is. And the total variable costs are all of the TC terms that have a Q in it. So this has a Q, this has a Q, this has a Q. This one doesn't, which tells me that the $5,000 is my fixed costs. All these other, these first three terms, if I just looked at the first three terms, that would be total variable cost without the 5,000 in there. So then average variable cost is just taking each of these first three terms and dividing by Q. So it's essentially average total cost equation, but you just get rid of the 5,000 part of it. So, and then marginal cost is the derivative of total cost with respect to the Q variable. So you've got your total cost equation here. Derivative of this term means you pull the 3 down, multiply it by its coefficient. So 3 times 0.00002 equals 0.00006. Then you get Q squared. The second term, 2 times the 0.083 gives you 0.166. And again, you reduce the exponent by 1, so it just becomes Q to the first, or just Q. 46.5 times Q to the first, take its derivative, means you pull the 1 down, multiply it by 46.5, so it's still 46.5. Then it becomes Q to the 0th power. Anything to the 0th power is just 1. So 46.5 times 1 just leaves you with 46.5. So again, you'll need to, if you are just starting with data like this, then you're going to need to figure out a way to get an equation out of it, and then do the algebra, the calculus to get those other terms. That's how you would solve the practice problem. I can't speak to what you might do for anything that's graded, but that's how you would solve the practice problem.
Okay, thank you.
Anyone else? Pause the video again.